Okay, welcome to Section 1-5 Notes, Day 1, and this is on angle pairs. So we have 4 different types of angles, kind of key terms that we need to know, and we're going to use these words throughout all of geometry. So they're really important to kind of get the difference between these down. So adjacent, just like we talked about with the Section 1-4 notes, I think it's really helpful to think of what does that word mean in everyday life. So think about the word adjacent. And the way I think of it is the word next to. It actually has us written right here, right next to each other. So, like my room and Mrs. Denson's room are adjacent to each other. They're right next to each other. We share a common wall. So that's one way to think of that. The geometry definition says two coplanar angles with a common side and vertex, but no common interior points. So another way I like to think about it that I'm going to add right under the next two is that there is no overlap. Okay, because they're right next to each other. They share a side, they share a ray, but they don't overlap each other. So if I go and draw a picture of that, I'm going to go and draw two adjacent angles. So I'm going to put some points on these angles, and I'm going to go ahead and stick an A here, a B here at the vertex, a C over here on this ray, and I'll go ahead and put D here. And so now I'm referring to these two angles being adjacent or right next to each other. And I'm going to specify off to the side which two angles are adjacent. I'm going to say angle ABD and angle DBC. Again, you can name those two angles differently than I did, but the B does have to be in the middle because it's the vertex. And I'm just going to say are adjacent. And for angles, instead of writing out the whole word, I'm just going to put a little angle symbol with the S. That's a good way to abbreviate it. Okay, on the next one, we have vertical angles. So vertical angles are two congruent angles. Vertical angles are always congruent to each other. So two congruent angles formed by two intersecting lines. Okay, and you can see here I have the wording written across from. The other way I like to think of about it is vertical angles form an X, if you want to add that as well. So they form an X. All right, so if I draw an X, which is basically just two lines intersecting each other, and I go ahead and label these lines with points, I've got angle A, I've got angle E, I've got D, I'm going to put C over here and D over here. Okay, so I could name two different pairs of vertical angles from this picture. I could name angle AED and angle BEC. That would be a pair of vertical angles because these two angles are right across from each other by two lines that form an X. And so I therefore know that these two angles must be congruent to each other. Okay, if I switch colors here, then I can also find another pair of vertical angles. And in this case, it'd be angle AEB and angle DEC. So I would be referring to this angle and this angle. And again, they would be congruent to each other. I'm going to put 2 marks because they're not necessarily the same measure as the other two congruent angles, but they would be a pair of vertical angles. Okay. Next type of angle is complementary angles. And that is two angles whose measures have a sum of 90 degrees. And you can see here I already have that add up to 90, but there's different ways that can happen. Those two angles could be adjacent to each other, but they don't have to be adjacent to each other. So if I show you a picture like this, And I go ahead and put the little right angle symbol in there. And then I go ahead and draw another ray like this. And I'll go ahead and put an angle 1 in here and angle 2 in here. Okay, so I could say that angle 1 and angle 2 are complementary angles because I can tell for sure that those are two angles that add up to 90 degrees based on that right angle symbol. Okay, but another scenario would be I could show you, say, angle A that is 60 degrees, and I could show you angle B that is 30 degrees, and I could also tell you that angle A and angle B are complementary to each other because they add up to 90, because I know that 60 plus 30 equals 90. Okay, so it doesn't necessarily have to be that they're adjacent or right next to each other, but they can be. All right, so let's move up the screen so we can do the last wording here, which is supplementary. Let's go there. So supplementary angles are two angles whose measures have a sum of 180. And similar to complementary, they can be adjacent to each other, but they don't have to be. Again, add up to 180. And if I show you a straight line, and I'll draw another angle to be formed there. Let's see, I'll just put an angle 1 in there and a 2. So I could say that angle 1 and angle 2 are supplementary. I'm just going to abbreviate it. But I know that they are a pair of supplementary angles because there's two angles forming a straight line. So I know for sure that, from here, this whole angle has to be 180. But another scenario we could have is I could have one angle that, I'll call that one C. Let's say that angle is 120. And this other angle, I'll call it D, is 60. Well, I could also say that angle C and angle D, oops, I need an angle symbol there. Angle D are supplementary. And I know that because 120 plus 60 adds up to 180. So again, they don't have to be adjacent to each other, but they can. Okay, on this next part on example 1, I think it would be a good idea for you to pause the video to try example 1 based on what we just talked about, and then to join back on here and kind of see how you did. I'll kind of talk through what the answer should be. One thing that get it all moved up. Okay, one thing to think about is they're true-false questions. But they are also asking you to explain your answer. So I want you to find the angles that they're referring to. Again, when they give you 3 letters, make sure that middle letter is your vertex. Think about the word that they are referring to and see if you think that statement is true or false. But once you answer true or false, you're not done. You need to write down an explanation. So again, pause your video, try that, and then you can come back in a minute and check your answers. Okay, welcome back. So go ahead and check example 1 as I talk through it. On A, it says angle BFD and angle CFD are adjacent angles. Remember, adjacent means right next to. And if I look at BFD, that is referring to this whole angle from here to here. And angle CFD is talking about this angle from here to here. Okay, those are not adjacent to each other. So I would put false. You could have a different reason than I did. You may not have worded it exactly like I did, but I have that they have common interior points and that they overlap each other. Okay, if they were to be adjacent, they would have to be right next to each other, sharing a ray, but not overlapping each other. Okay, if we look at B, it says that AFB and EFD are vertical angles, and that is false also. Different ways you could explain that answer. If you look at B, F, and E, Remember how we said vertical angles have to be formed by intersecting lines? Well, BFD, BF, and E are not a straight line. Those points are not collinear or on the same line. So that's why it doesn't work. The AFD is fine. AF and D are all on the same line, but the BF and E is what makes it not work. But another way I could word it is I could say ray FB and ray FE are not opposite rays. So that's another option. On C is referring to let me get this erased. On C, it's referring to AFE. So that goes from here to here, and BFC from here to here, and they're complementary. Again, we talked about complementary as two angles that add up to 90, and that is a true statement because I can add up this 62 plus the 28, and that equals 90. So I therefore know that those two angles must be complementary to each other. Okay. And let me move this up a tab. Okay. I'm having trouble moving it up. Bear with me. It's being a little touchy. Okay. Okay, if we go ahead and see what's going on here, it says note about reading diagrams. Things you can assume is that angles that look adjacent are adjacent, or right next to each other. A straight line is a straight line and therefore 180 degrees. And angles that look like vertical angles are vertical angles. Again, if you can see, it's two intersecting lines. You cannot assume that angle measures, except for 180, are acute, right, or obtuse. So just because an angle looks acute and looks less than 90, we can't assume that unless you know the measurement value, or they give you some hint of that, or right or obtuse. And angles or segments are congruent. Just because two segments or angles look congruent, we cannot assume that. We have to have markings on there or measurements on there or something to help us know that for sure. So in example 2, based on that information and based on some of the other things we've talked about, it's asking, can you make each conclusion from the information in the diagram? And once again, to explain your answer. So here on A, B, C, D, E, and F, you can just answer yes or no if you can make that conclusion or not, and then give a reason. So again, I would like for you to pause the video again, try these. I think it's just good practice to see if you're kind of getting it, and then you can come back on and kind of see how you did and fix any if needed. Okay, welcome back. So let's go through this and you can check your answers as we go. Again, I highly recommend you take the time to fix them if needed, and kind of learn what you got right, what you got wrong. So on A, it says TW is congruent to WV. If you look at that, TW and WV, I see those congruent marks. So yes, I know that those must be congruent because that's what those markings mean. On B, it's talking about PW and WQ. So it's referring to here and here. And I would say no, because they do not have congruent marks and they haven't given me any other indication to know that they are congruent to each other. Erase those marks so we can talk about some others. Okay, if we look at C, it says TWQ is a right angle. So if I look at angle TWQ, which is this angle, there is no indication to know that it's a right angle. It does kind of look like a right angle, but there's no right angle symbol. It doesn't talk about perpendicular. So I cannot, it doesn't have a 90 degrees in there. So I would say no. I do not know that that is a right angle. On D, it says TV bisects segment PQ. And we talked about the word bisect means. I remember we said that means cuts in half. So it's telling me that TV is, it's saying, do we know for sure that TV is cutting PQ in half? And I would say no, because, PW right here and WQ do not have congruent marks on them. And so I don't know for sure they're congruent. Again, they kind of look congruent, but I can't assume that. If I look at E, it's referring to angle TWQ, so this angle, and QWV, which is this angle, and it wants to know if they are congruent to each other. So again, no, they do kind of look like they're congruent, but I cannot assume that. I put as my reason, there's no congruent arcs in the angles, there's no right angle symbols on the angles, so I don't know for sure that they are congruent. Getting a lot of no's here. But then now it's asking on F, does the measure of angle TWQ, which I already have that one starred, and the measure of angle QWV equal 180? I can finally say yes. Okay, I've had a lot of no's, but I can say yes to that because I can see that these angles are forming a straight angle, which I know has to be 180 degrees. So I've got yes for that. Okay, so now if you look down at example 3, this is again something else that you can do, and I highly recommend that you do that. It's just again helping you make sure that you know what these words mean. So I would pause the video again, try to answer example A, example 3, look back at what those words mean if you need to, and then you'll get back on and check in just a moment. Okay, welcome back. So hopefully you tried those on your own, and then you can check with mine here on example 3. Keep in mind that you could have named the angles differently than I did, so don't start erasing even if yours look different than mine. You could name a lot of these angles with 3 letters. I just prefer to name it with the number if possible, just so it just kind of saves me some time and saves me some writing. But if you named all of these with 3 letters instead of the numbers, that is completely fine. So on A, it's saying 3 pairs of adjacent angles. Remember, adjacent means right next to. So I said, angle 1 and 5 are adjacent to each other. I said angle 3 and angle 4 are adjacent to each other. And I referred to angle 2 and angle 3 being adjacent to each other or right next to each other. You could also have angle 1 and angle 2, and you could also have angle 4 and angle 5. And again, if you named it differently than I did, I moved it. Now I got to find the right spot again. Okay, if you did it with 3 letters, that's completely fine. On B, list 2 pairs of vertical angles. So again, vertical angles are formed by that big X, by 2 intersecting lines. And if I look in this case, angle 2 and angle 4 are a pair of vertical angles, and I have that listed. And then the other pair of vertical angles would be angle EFD. So I can see EFD goes from here to here. And then the other angle, AFC, goes from here to here. But you can see again, AFD forms a straight line, or you can see 2 opposite rays, and EFC forms a straight line or 2 opposite rays. So, this angle and this angle again would be vertical angles and therefore would be congruent. All right, then on C, it's asking for a pair of complementary angles. And we can tell that those 2 angles, angle 1 and angle 2, are complementary angles because of this right angle symbol right here. And so I know that those 2 angles are complementary. And then on D, it's asking for 2 pairs of supplementary angles. Remember, supplementary angles are angles that add up to 180. So I first listed angle 3 and angle 4. I can see these 2 angles are forming a straight line together, so therefore they are supplementary or add up to 180. And I can also see that angle 2 and angle 3, which would be this angle and this angle, form a straight line and therefore add up to 180. You could also, there are some other options of angles, but I just named those with 3 letters. So again, if you wanted to see some other options, that would be fine. It's just that there's 2 numbers making up an angle. You can't really call it by those 2 numbers. So you would have to use the 3 letters instead. Okay. All right, now we've got some more definitions to go over. So let me move that up. So if you look here, it's asking about a linear pair. And it says a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles of a linear pair form a straight angle. And I can go ahead and draw a picture of that. And I can label some points here. I'm going to go with A here. I'll go with B here, C here, and D here. So one thing I could say about this picture is I could say angle ABC and angle CBD form a linear pair. Okay. Then the linear pair theorem, it says if two angles form a linear pair, then they are supplementary. Okay. And on example 4, it is telling you that these two angles are a linear pair, and they want you to find the measures of the two angles. So I would recommend here drawing a picture. If I know it's a linear pair, then I know it is two angles forming a straight line together. And I would go ahead and if it says KPL and JPL, I can see that the side they share is going to be PL, that ray they share. And I know that since the P is in the middle, that means P is at the vertex. So you kind of have to pay attention to some of those little clues. It doesn't matter if I put K here on the other side and, same with the J. All right, now I think it's helpful to go ahead and label the picture with the information that is given. I can see KPL is 2x plus 24. And I can see JPL is 4x plus 36. And now, again, if it's a linear pair, I know that therefore those two angles are forming, are supplementary or forming a straight angle. So I know that this whole thing from here to here has to be 180. And I just think it's helpful to go ahead and put that in your picture. And then I think it'll help you to set up your true equation based on that. So I'm going to go ahead and pause the video again. I recommend setting up your true equation, solving for x, and then plugging back in to find the measure of the two angles. Okay, so go ahead and check your answer here. You can see that I set up my true equation. I solved for x and got 20. I plugged back in to get my two angles, which are 64 and 116. Again, I could do a quick check. I'm kind of running out of room, so I'm not going to write it, but I can do a quick check and add up 64 plus 116 just to make sure it gives me the 180, and it does. So then I know that I've done that work correctly and haven't made a careless mistake there. Okay, the next word is angle bisector. Remember we said bisect means cuts in half, but what are we cutting in half? In this case, an angle. So here are the definitions as a ray that divides an angle into two congruent angles. And then on example 5, this one is again just some more practice of setting up a true equation and solving based on the information given. So if we go ahead and move this up here, it says, according to the markings, what is ray GH? Okay, and if you can't see it, this does have a little arrow right there that is referring to the ray. And that ray is an angle bisector. And I can see that because of the congruent marks on the angles. So I can say that it is the angle bisector of angle FGI. Okay. And I, for some reason, didn't get marked on here, so I'm going to stick it there. All right, so if I want to solve for x, I want you to think now, what is a true equation I can write to solve for x? And again, if two angles are marked congruent, I therefore know they are equal to each other, so I can set them equal to each other. Again, it's not always going to be the segment and angle addition postulate, where something plus something equals something. In this case, I'm setting them equal to each other. Now, if I go and solve, I end up with x is equal to, if I add 14 to both sides, I get x is equal to 11. Now I can plug back in to get these angles that it's asking for. Technically, I'd have an m in front to say the measure of HGI is 4x minus 14. I'm going to go ahead and plug in the 11. And if I solve, I've got 44 minus 14, which is going to be 30 degrees there. Okay, I'm going to box it. That's one of my answers. And the measure of FGH is 3x minus 3. So I've got 3 times 11 minus 3, 33 minus 3. So measure of angle FGH has to be 30. Okay. And then from there, I've got the measure of angle FGI. And in that case, I know that if each angle is 30, I can add up to get what the whole big angle is, which in this case is 60. And so FGI is 60. Okay, so good double check there. All right, on example 6, here it is telling me that ray BD, again, it's a little hard to see that little arrow, bisects or cuts in half angle ABC. Okay, so that is telling me that this angle must be congruent to this angle. And now I want to set up a true equation. So if I look at this, it says ABD is x plus 3. So I like to go ahead and mark it in my picture. It's telling me ABC is 3x minus 5. So I know that this whole angle from here to here is 3x minus 5. And they want me to set up a true equation. So I want you to think for a minute. If you want to pause the video and go and try this yourself first, you can. But if you want to kind of get it started with me, then think about it. Okay, we do know bisect means cuts in half, but a common thing people would write here is they would go x plus 3 equals 3x minus 5. So I want you to think about that for a minute. Would it make sense that x plus 3, this little angle, is equal to 3x minus 5, this big angle? And to me, no, that does not make sense. If I know that these two angles are congruent to each other, I know if one's x plus 3, the other is x plus 3. So I can put that in the angle, and then maybe that will help you see how to set up that true equation. In this case, we've got x plus 3 plus x plus 3 is equal to 3x minus 5. Then you can solve for x, and then you can plug back in for what it's asking for. So I'm going to pause the video one more time, let you finish this problem, and then we can check back and make sure we got the same thing. Okay, so if you go and check to see how you did here, once you solve for x, you should get x is equal to 11. Once you plug back in to get the measure of angle ABC, you should get 28 degrees. Again, if you want to double check that, you could plug that 11 in, here and here. And if I plug it in, 11 plus 3 would give me 14, and 11 plus 3 would give me 14. And we just said the whole thing is 28, so that would make sense since 14 plus 14 is equal to 28. All right, thank you very much. Have a great day.